Good morning, everybody. Welcome to this second webinar from the NewWave project. I'm Giulio Poggeroni, the Communication Dissemination Manager of NewWave, and I will moderate this session on engineered wood products. What's the way forward? As I said before, this is the second episode of the NewWave webinar series, and I can remind you that on the website you can find our previous episode, which was on modified wood products. Today with me, we have Luis Otero Vasquez from the FORESA Technologies, partner of the NewWave project, who will lecture us about the engineered wood products. The brief introduction I wanted to propose you about NewWave. For those of you who are not familiar with the project, NewWave is a Horizon Europe project that started 2 years ago. It deals with sustainable bio-based products for the construction industry, and it has a consortium made up by several European partners that you see here. Some others have you the chance to meet them in the previous episode. And the main objectives that NewWave has are to transform existing manufacturing lines for products that are using fossil elements of fossil origin and create new bio-based value chains utilizing biomass residues. The aim is to make these new products having similar or better characteristics as the product compared to the products that we are aiming to substitute. And they also have to be non-toxic and recyclable. Here's an overview on the 4 value chains that we are developing in NewWave. The last episode addressed the new modified wood products, while in this episode we are focusing, as I said, on the new engineered wood products. So this gives me the chance to pass the floor to Luis. Luis, good morning, and I'm going to share your presentation.
Okay, thank you, Giulio. Good morning. Good morning, everybody, and thank you to the audience. And as you said before, I will speak a little bit about this interesting topic. But first of all, some few words about FORESA Technologies. FORESA Technologies is a 5 years old spin-out from FORESA. So the expertise and knowledge in polymers and chemistry comes from the very beginning, from the foundation of FORESA in 1974. FORESA business unit has 3 industrial sites in Bordeaux, France, in Aveiro, Portugal, and here in Caldas de Reis, where are also FORESA Technologies. Caldas de Reis is close to Santiago de Compostela. Next, please. Okay, regarding our main products, FORESA Technologies produces adhesives and products mainly for wood industry, but also for other applications. From the very beginning, our main technology was the oxidation of methanol to formaldehyde. And from this formaldehyde, we produce thermosettings using urea, melamine, and phenol. So we produce urea formaldehyde, melamine formaldehyde, melamine urea formaldehyde, and phenol formaldehyde thermosettings. Moreover, we also produce thermoplastic products. We carry out the emulsion polymerization of vinyl acetate monomer to produce homopolymers and copolymers, and also emulsions mainly for wood and wood sector and insulation materials sectors as hydrophoban, using wax paraffin and mineral oil. But for the last 15 years, we are focused in developing bio-based material from biomass or agro waste or flour and so on. So this aligns perfectly with the topic of today. Next, please. Okay, regarding this research on our base products, we, in the last 15 years, as I said before, we carry out several European projects, but also internal projects from biomass or agro-waste to extract the polyphenolic compounds, lignin and tannins mainly. And we, when we arrive to a solution or a product, we fill the patent and register the trademark name. So we have our lignature products, resins based on lignin, pinature resins based on mainly on tannins chemistry, FORESA based on protein flour, and biowax from bio-based oil and fats. Additionally, we also have another chemistries dealing with sugar, and also was starting point. Okay, next one, please. Okay, the next part of the presentation, I will explain the technical challenges and the sustainability issues in the engineered wood sector, and we will focus on MDF as an example, but it's quite similar for OSB, particle board, and plywood. Any additional question after the presentation, we will may answer. Okay, next, please. Okay, regarding technical challenges, for us is one of the main is to move from oil-based materials, from oil and gas, to bio-based ones. So that's the point. We are working a lot in bio-based resin and additives. Additives means emulsions, catalysts, etc. Another important topic is the reduction of the final product of the volatile organic carbon molecules. Also, the recycling of the final product. It's also an issue we are working a lot. And it's also general, the water is reduction and the energy efficiency of the process. In this case, water is reduction. FORESA is a pioneer because our process, our industrial process, use the closed loop regarding the water. It's a zero water discharge. And regarding energy efficiency, we are working a lot to optimize the electric consumption, but also to move to renewable energy using PPAs. Another topic of interest and another challenge is to the recycling in the sense of downcycling and upcycling. But this is a graphic of the process, and it's as you see, there are a lot of points where we need to improve all these issues depending on the bottlenecks in the process. Okay, next one, please. Regarding the sustainability challenges are not different from other sectors. One of the challenges is the carbonization. In FORESA Technologies, over the 60% of our projects are dealing with the carbonization and reducing the carbon footprint of our processes and products, and also to try to push forward our raw materials to reduce also the carbon footprint. Another topic is the water reduction and energy efficiency, as I said before. Other topic is important for our sector is certification. I mean, several brands and seals like Cradle to Cradle, EcoBodies, ESCC, and so on, depending on the sector, depending on the market, depending on the product, we need to create this certification. Another important thing is to create processes and products safe and sustainable by design. In this case, FORESA Technologies has integrated regulatory affairs in our area. So just before starting a project, REACH issues and sustainability and safety topics are very in mind just prior to start the project. So this is important because from the very beginning, we take into account these issues. Circularity is also important because we need to move from a linear economy to a circular economy, and we have in mind this point in each new project. And of course, NewWave project also fits perfectly with this topic. And greenhouse gases emission, we need to avoid or to carry out abatement of these gases. For instance, the CO2, but also other organic molecules. Next, please. For us, NewWave, it's absolutely aligned with our goals and objectives. And in this case, our work is focusing work package 5, and we'll explain a little bit our work in this nice project. Next, please. Okay, NewWave project is a research and innovation action in Horizon Europe. The coordinator is BTG. We are 11 partners: BTG, AEP, ABECOM, FORESA, FORESA Technologies, Blue Synergy, TFC, HAG, ETA, ABA Biochem, and InnoReview. And the budget is about over 5 million euro. Next, please. Okay, the idea of the project is to use residual biomass to create several streams and to put on value these streams using a fast pyrolysis technology. And in this case, FORESA will use the bio oil that comes from this fast pyrolysis, and we will use these fractions to introduce in our products and to develop new products to substitute the oil-based raw materials for this fraction. Okay, next, please. In this case, we will use the lignin fraction, several fractions with different characteristics, molecular weight, aspect, pH, and so on. So we will analyze these lignins. We will produce resins different for each application. It's not the same resin for plywood than a resin for MDF. And also, once we have this resin, we need to adjust the manufacturing of the composite. It's not the same plywood than an MDF, and it's not the same plywood with A lignin fraction than B lignin fraction. Another goal in this project is to obtain a fully bio-based solution using green phenol and cresol obtained by rock, and also use hydroxymethyl furfural to use a 100% bio-based resin. Because in the case of lignin, we are trying to increase the substitution of fossil phenol for lignin, but we also have a non-bio-based fraction, in this case, that comes from formaldehyde. So the idea of the fully bio-based solution is to substitute the formaldehyde for another bio-based aldehyde, in this case, hydroxymethyl furfural. Okay, next, please. Okay, the duration of the project is 3.5 years. And okay, this is the chronogram with the activities, and the final objective is, as I said before, to produce a 100% bio-based resin. Okay, next, please. The objectives of this work package are design green panel boards, plywood, and MDF based on this pyrolytic lignin. The idea is to use the highest content of modified lignin as we can. And in a second stage, the idea is to develop a fully bio-based plywood and MDF using this biophenol and biocresol, and also the HMF. And the idea is to produce enough amount to test the possibilities of this technology, to carry out the scale up of these products. Next, please. So more or less the tasks are: we carry out the characterization of the lignin fractions from BTG. In this case, we analyze the CH and S, the molecular weight, the pH, viscosity if the product is liquid, and physicochemical characterization. The next step is to see the suitability of each lignin to use in phenolic resins to substitute the phenol for lignin, to try to change the amounts or the degree of substitution of this phenol, and also to design new resins to overcome the problems we have when we characterize the resin. After that, we scale up and we cook these resins in two streams: one resins for plywood and another type of resins for MDF. And finally, once we have the resin, we need to adjust the conditions of the line to produce the panels. The conditions are press temperature, pressure, cycle press, etc. And in this case, I guess probably it's better to show you the plywood. This is a sample of the plywood. We may produce 50 by 50 centimeter, and these are samples of MDF. Next, please. Once we have the resins, we analyze them. It's also important, the physicochemical characterization, but one of the main parameters is the reactivity. We measure the hardening time, also the free formaldehyde of the resin, and the free phenol. Additionally, we analyze the molecular weight distribution. In this case, not only the average molecular weight. For us, it's really important to see the graphic, the distribution of the different molecular weights, because it has a relationship with the properties like cold tag, reactivity, and behavior in the process of manufacturing the composite. It's important also to carry out a rheometer test, that means mechanical curing. We have a rheometer using disposable plate in an oscillatory analysis. We measure the properties of the different resins. And also we analyze the chemical curing using DSC, differential scanning calorimetry. In this case, we measure the enthalpy of the formation of the bonds during the curing, and we measure the temperature of the peak and also the area below the cure. And all these techniques are complementary and they give us a lot of information, really useful for the design of the following experiments. Next, please. Okay, regarding the manufacturing of plywood, we carry out different degrees of substitution using 25%, 50%, 75%, and 100%. In the case of plywood, we have several qualities depending on the final use. We have class 1 is just for interior use, class 2 for a humid environment, and also class 3 for exterior use. We have reached 100% of substitution, and we don't meet the standards for class 3, but it's really important to have 100% of substitution, this panel, because in the market, one company in the north of Europe and FORESA, we have a 50% of substitution of phenol for lignin. And okay, it's okay, but 100%, it's also really, it's a feat, because even for class 1, it's an important achievement. Next, please. Okay, we use different fractions to produce also MDF resins. Up to now, we carry out the substitution of 25% with nice results. Those are the samples with 25% of substitution of phenol for lignin. And right now we are testing 50% and 75% of substitution, and we will show the results in the next NewWave meeting. But the results are quite promising. Okay, next, please. Okay, in this case, we also use the same tools to have the information to design and to fine-tune the properties. And in this case, we also use TGA to measure the solid content and the temperature where start to degrade the products. But in the case of DSC, rheometer, and GPC, or size exclusion chromatography, is the same insights that in the case of plywood resins. Okay, next, please. In this case, we also have, as the case of plywood, several qualities. We have a standard MDF for interior use, but also moisture-resistant MDF, sorry. And in this case, we are testing this MDF. In the very beginning, during the pilot plant manufacturing, we had several problems. The problems is you may see in the picture the lamination, let's say the steam liberated during the process break down the panel, but changing the conditions of the press, we were able to overcome this problem, and we have panels with no problems at all. And in this case, we are testing 50% and 75% of substitution, but we will try to test also 100% of substitution. Next, please. And okay, in our understanding, our take-home message is we are learning in this project is a lot of room to improve our materials, and the challenge is to increase the degree of substitution of fossil-based raw materials for bio-based ones. And okay, we are in this way, and we have a lot of commitment in the process and a lot of expectations.
Thank you, Luis. Actually, I would like to bring up one thing before going to the questions, because in the project we have envisaged that these products, these MDF panels that you described before, will be tested in a real environment, because they will used in a let's say demo building, a small realization that will take place in Slovenia at the premises of our partners in a review, right?
Right.
So
Yes,
can you say some more details of how this will be used as for interiors or other parts?
Yes, in this case, we have the previous experience of a rehab project, and we also have a demonstration house here in FORESA. And in this case, these learn lessons were really useful in the development of this project. And the idea is to increase the performance of the products at the highest degree of substitution. But for sure, the demo in a review will give us useful insights to improve or even to carry out the scale up of this technology. Because the final goal is to scale up and to put in the market these solutions.
Yeah, thank you. So moving to the question, there are some ones. However, I see that some questions are more related to the production of the fast pyrolysis bio oil. For those of you who are listening to us, this is a part of the project that is led by BTG, Biomass Technology Group from the Netherlands. So we'll try to go through some of the questions, and then Luis, tell me if those are more pertinent to your activity, or if we will redirect our attendees to offer another time for replying. So what has been your experience with managing VOC, such as furan derivatives, that are inherently present when using HMF-based resins? What solutions have you implemented to address these emissions?
Okay, in this case, we are focusing for several years to decrease the formaldehyde. Formaldehyde is also a VOC. And right now, we are in a quite low level of exposition. But VOC sometimes means natural occurring compounds in wood. That means in pine, for instance, you have limonene, terpene, and so on. So the challenge is to try to reduce these products. So the idea is to decrease the chemicals, for instance, formaldehyde and also HMF. We have no experience in the levels of HMF VOC, but probably in the last part of the project we will have some information about that. And regarding the natural occurring VOC, we are trying to optimize the process
Okay, thank you.
because the chemistry of the is okay. The evolution create a boot with its own molecules, and we cannot change. We need to adapt the process to minimize this natural occurring box.
Okay. So there's another question. How do the bio-based polyurethanes used in wood composites enhance the circularity and recyclability of wood panels compared to conventional polyurethanes like Huntsman's I-Bond?
Okay, in this case, we have no experience in polyurethanes. In some other projects, like rehab, there was a part of non-isocyanate polyurethanes, but sorry, but it's a chemistry we don't know.
Okay.
But probably it's quite challenging, for sure.
Okay, answer to that. Then we have another question regarding fast pyrolysis, but these are for BTG. So I encourage all of you who have questions regarding fast pyrolysis and the fast pyrolysis bio to send an email to NewWave. You find the email on the website, and then we will revert to BTG.
Julio, or maybe to create a new webinar on fast pyrolysis.
Yeah, which actually it's something planned, but I cannot tell you the exact timing at the moment.
Okay.
Yeah, in fact, there is also a question regarding the fact that extracting lignin from bio oil can be energy intensive, cost and complex, which could challenge the alignment to the principles of the bioeconomy. Well, actually, this is what BTG is addressing with the TCF process. There are some info material and news on the TCF process on our website, so I encourage you to look at that, waiting for the webinar focusing on the fast pyrolysis in the framework of NewWave. Another question, although these resins are more suitable, the longer curing time reduces manufacturing efficiency, which poses a challenge to their industrial adoption. What do you think about this?
Yes, this is one of the main concerns in the beginning of the project and also in other projects dealing with lignin. One of the problems of lignin is the lack of reactivity. So we are trying to overcome this problem, modifying the resin. So we need to change the recipe and to create new synthetic fruits to overcome this problem, and also to adjust the manufacturing processes. But answering the question in a more accurate way, yes, probably you need sometimes to decrease the press factor and also the productivity. But it's a topic we are working on.
Okay,
And probably
thank
during
you.
the process of scaling up the technology, we will keep on working on that.
Okay. Then we have a question. I don't know if you are the partner to ask for, but they're asking, could you comment on the regulatory aspect of getting some of these pyrolysis liquid derivatives into the market?
Yes, for sure. We will have some issues regarding that, but in this case, BTG will carry out a deep characterization of the product to inform the authorities with competence in this term. In this case, ECHA. but that's a point we are used to work with these requirements because, as I said before, REACH is a main topic of each new development because it's really important to have and to share all the information with the European Commission and with the authorities. But for sure, some actions should be taken.
And this gives me the chance to remind something to our attendees that the WAVE is a research project. The TRL level that we will reach at the end, it's not that of full market readiness because it's a research and innovation action. So the purpose of this project is also to create new grounds for research and market products that then once the results will be presented to the European Commission, this will help the Commission drafting new policies, new rules. Of course, not just NewWave, but the other dozens and dozens of projects that are working and carrying on activities in this field. Another question, why not focus on low-hanging fruits like HDF instead of MDF? With HDF, energy consumption for resin curing is less of a concern compared to MDF.
Okay, the idea is to develop MDF because the thickness is higher and at a lab scale or pilot scale is easier to work on, for instance, 17 or 18 millimeters wide compared with HDF is much lower and at this level is not as useful at this as research purposes, let's say, but probably no, for sure. The results obtained for MDF process will be extrapolable to HDF process because we have experience with other chemistries.
Okay. Then there's another question, which I also can help to answer because it's what other bioproducts results from the fast pyrolysis phase? Do you generate biochar? Actually not, but if you look at the website, there's a series of fact sheets detailing the 4 value chains that I mentioned at the beginning. The idea is that from the pyrolysis oil, we fractionated the pyrolysis oil into its fraction, and in the case of this manufacturing line that we are talking about today, we talk about lignin. But then if we take, for example, the previous episode of this webinar where we talked about engineered wood, in that case, the fast pyrolysis oil is used to impregnate the products to make more resistant to extreme weather conditions and so on. But if you browse through the materials on the website, you will have an overview on that. And also I refer back to the previous webinar that you also find on the website. We have answered to that, of course. How do they manage to separate the desired fraction from pyrolysis by oil to produce resins? Doesn't the desired fraction have a very low yield? Again, this is more for BTG. What do you think?
Yes, sure.
I'm
Yeah.
pleased to see this interest in the pyrolysis by oil, but don't
It's an
worry,
interesting topic.
we will
Yeah, yeah.
address this in the one of the other 2 series that we are planning for the next year. Let's see here in the chat box. I also saw some comments. I also have pleasure to see that the attendees are debating in the chat box. A question. What was the target density of your experimental MDF? All 1 gram per cubic centimeter, or did you try more than 1 gram per cubic centimeter?
The density of the MDF.
The target density of your experimental MDF.
In our case is 0.6, 0.7 grams per cubic millimeter. It's
Okay.
the standard MDF. 1 gram per cubic millimeter is more for HDF, for instance. But in this case, for a higher thickness, is circa 0.6, 0.7.
Okay, I see. Okay, there's another question from an attendee who, the professor has worked with resins and bioresins, and the question is, did you try with continue press? Did you perform curing properties of the resin?
No, because at pilot scale, we don't have a continuous press, but with experience of more than 40 years, we know how to move from a press plate at lab scale to a continuous press in the MDF or particle board mill.
Okay. Okay, we have answered to that, and we are also okay. Okay, this is about the biomass that we handle per day in the BTG plant. So that's it for the question. We are also approaching the time limit that we agreed upon. So I thank you, Luis, for your participation, and I
Thank you to
also
you.
would like to thank all the attendees who have actually actively contributed to this session.
Yes.
I would like to remind you that we have added the in the chat box the link to the NewWave project website, where you find plenty of materials and leaflet, fact sheets, and also the newsletter that we published this summer with the latest updates, including updates related to the engineered wood part. So I encourage you to look and download the materials. I would like only to remember that in the past year we have teamed up with other 6 projects, with our 5 projects. We are in total 6. Developing same and similar value chains. These 6 projects have teamed up in the biomatters cluster, which is basically a network of projects cooperating and carrying joint activities. We had the chance to organize an event during this year, European Biomass Conference and Exhibition in Marseille, and we presented the respective approaches, value chains in front of the an officer from the European Commission, and we also managed to develop a nice discourse, a nice discussion with the European Commission, who is interested in witnessing the results coming from these projects. And this will be more important in the next 2 years of activities in which the Commission will pay attention to the results of this project that will help fine-tune rules and policy that might come in the future, because we know the bioeconomy topic is a very hot one, and for sure we will see developments in this field, also the regulatory field. If you have other questions, if you think we didn't answer entirely your questions, I encourage you to send them in a written form to the email that you find in the website, or through the contact form, and we will try to answer them. We are planning to schedule at least other 2 webinars in this series regarding the other 2 value chains that we have not covered. And in one, for sure, we will address all your questions regarding the fast pyrolysis oil. So thank you, Luis, once again.
Thank you to you. Thank you to the audience.
And thank you to our very active audience. Thank you and have a nice day. Goodbye.
Have a nice day. Bye-bye.